Great. This is for KAP on Monday, August 30th. We're talking about, this is just a KAP lesson, so hack as students go find your recording. Quick check that you did your Google form last night. Again, if you had trouble logging in, make sure you're logged into your KE email. Our test review class is due on Wednesday. Also, make sure you're working on that. I would do like 3 or 4 problems a night. If you get to something we haven't talked about, like inter quartile range, save it for tomorrow. Jumping into today's lessons, we're going to be comparing graphs now. So maybe we're given 2 dot plots, maybe we're given 2 similes. We're going to take our prior knowledge and we're just going to compare the 2. Okay, so looking at this, we're looking at dot plots that show the number of miles going per week for 2 different athletes. We have James on the top, Martin on the bottom. We are going to find, it says compare the spread of the dot plots by calculating the range. How do we calculate the range? Raise your hand. How do we calculate the range? Yes, ma'am?
Do the highest value
Very good. So we are going to use the outlier on the first one, and then we'll do it without the outlier on the second one. So go ahead, look at James. Okay, find his highest and lowest values. Raise your hand when you get the. Okay, raise your hand when you find that highest and lowest value. Shrinker, what did you get?
So for James, his lowest value would be 5 3/4.
5 3/4, or what's the decimal? Same thing.
5.75.
5.75. I'm going to do decimals because I'm going to have to subtract and I'm not going to save myself. Okay? Yes. Between 5 1/2 and 6, there's 5.75. Shrinker, what was the highest?
The highest would be 9 point or 9.4.
Oh, be careful. That would be 10. Very good. So the highest is 10. So to find that spread, again, we subtract those values, 10 minus 5.75. Now, real quick, check yourself before you wreck yourself. When I subtract, especially with decimals, I need to line them up, okay? And when there are none, add them. Okay? Ready, set, go. All right, Etta, what did you get? Ooh, I love that. 4 and 2,500. Do y'all agree? I agree, and I love the math vocabulary to use it. Okay, now we're going to do it without the outlier. Remember, 5.75 is sort of, that's going to be our outlier in this point because it's sort of off by itself. Why do you think Ms. Lytle is not saying that those are outliers? Yes, ma'am. There's 2 of them. If it's happening twice, it's probably a habit. It's not coincidence. Okay, so what is that new low value? 7. I'm going to keep that high of 10 minus the 7 class. That would give me 3. Write that down. Okay, pause. For recordings at home, if you need to pause and play, because I'm going too fast. All right, now with Martin. Okay, find that high. What's the highest value? 10. What's the lowest value? 5.75. Is it the same numbers? Okay, look at us. Okay, so I'm just going to re-record that. 10 minus 5.75. Should our answer change at all? No. Hopefully not. Okay, but without the outlier. Same rule of thumb. What do we think the outlier is going to be in this case? 10. Okay. Again, in normal situations, I would still include it, but just for the sake of saying, we're going to not include it. So my new high is going to be 9.5. And again, I'm going to still include 9.5 because it happened twice, so it doesn't happen. So I need to do 9.5 minus 5.75. Take a pause, play when you got your answer. Micah, what did you get? 3.75. Y'all agree? Yes. Love that math talk too. Awesome. All right, so let's just fill in some spaces. It's talking about the spread of the data distribution for James and Martin is what? Okay, again, let's look at the ones where they included the outlier. What can we say about the spread of both of them? They're the same. It's the same because the highest and lowest data pieces for both because the highest, or what was the other word that we use for highest sometimes? Maximum, and the minimum, or the lowest. It doesn't really matter. The highest and lowest data pieces for both athletes was 10 and 5.75. Okay. Now we're going to talk about the shape. So I'm going to be talking about symmetrical or skewed. Skewed left or skewed right. So try and dig back from last Friday. For James, so looking at his graph, the data appears to be what? Because most of the data is what? So take a second to talk about James's graph and Martin's graph at your table. Pause at home, play when you're ready. All right, Marcos, at the yellow table, what do y'all say for James? Do y'all say symmetrical or skewed?
Skewed right.
Skewed. I agree that it's skewed. The direction, let me check. Okay, remember the skew, we're looking for which side the tail is on, so which one like it sort of dragged out. It's okay, it was an honest mistake. I appreciate the effort. So because the tail is on the class left side, therefore it's going to be skewed left. Again, thank you for taking a chance. It's going to be skewed left because most of the data is on that other side. I think that's confusing. I just like to say, oh, the tail is on the left, it's spreading out on the left, but there is a cluster, or the data is clustered together. I think. I know, what was the word that you used? What was the word? Clustered around. Clustered around. There we go. Okay, therefore, if I'm looking at Mark's, what would y'all say?
Skewed right.
Skewed right, very good. Skewed right, because most of the data is clustered around 7 hours. Okay. Again, that's just good review. Maybe you did forget skewed left, skewed right. That's good stuff to go back and study before our test later this week. Flipping over to the back. A little bit more on this problem. Now we are going to compare these centers. Okay, when we're looking at centers in this case, we're looking at the median for both. Median is talking about the middle, the very middle. Okay, so in first period, we were like, oh, let's list out all the numbers. And then the title was like, JK, LOL, because there's so many decimals in there. There's also, go ahead, count up and see how many numbers there are. To yourself. To yourself. Counting how many numbers would be in each list. How many did y'all get? 27. If I was writing out 27 numbers with decimals, it's going to be really long. It's going to be really extra. There's 27 dots for each. So let's try and practice finding it the other way. So again, if I'm finding the median, I'm finding the middle. So if I have 27 numbers in total, is it going to be a number or is it going to split two numbers?
Be a number.
It's going to be a number. So I'm going to have some amount, the median, and then another amount. Okay, so mathematically, how I would do that? If I don't count this guy in the middle, if I don't count my median, I'm looking at 26 numbers, right? Then I'm splitting evenly. So how many are going to be on each side? 13. And then 13. Again, that's 26 plus the median is 27. So the median is going to be what number in line? It's going to be 14. So I can just count my dots, right? The 14 numbers. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I think it's this guy. It could be any of the guys in that line, but I'm just going to check. I'm going to make sure, again, that there's another 13 on the other side. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Are we good with that?
Yep.
All right. So that median for James is, what's that number? 8.5. Median is 8.5. I'm going to go ahead and find it for Martin as well. Guess how many numbers we have? 27. Okay, so again, I'm looking for the median, which is going to be the 14 number. Okay, so count on your own. Okay? If you were unsure, or if it was a situation where it's splitting two numbers, that's when I would write out the list just to make sure, because it gets tricky figuring out where it splits. But for this case, since it is an exact number, that's why I'm okay having it this way. Okay, so 8.5 and 6.25. Dave was 8.5 and 6.25. The center of blank running, so the center of who's running is greater than the center of who's. Who is greater than who? Philip. The center of James is greater than Martin. Meaning the value of the middle pieces of data for blank are greater than the middle pieces of data for blank. So, of who? Greater for James. And Martin. Okay? Very, very good. Yes, sir.
I just have a question.
Yeah.
If there was like a million numbers in James and there was like a million numbers in Martin's, how would you like calculate the median?
The same exact way.
If there's like a million numbers. So
Okay, the 500,000. And if it's a million, it would split the 500,000 and the 500,000 and one.
So what if there was like a million decimals? Like,
I'm not going to give you that problem, so we're going to keep moving on. So, in your table or by yourself, if you're at home, I discuss or think about what does this mean, like talking about all this information we talked about. What does this mean in general about the two sets of data? Pause and play with your right. Raina, what did y'all's table sort of conclude this goes on? James runs more than Martin. Y'all agree? Yes. I would say like this is clustered up higher and this cluster is down lower. They're running the same number of days, but overall, in distance, one is running more than the other. Okay, what's going to happen now? There is another thing where you're comparing bar graphs now. Because I think y'all get the general hang of it, I'm going to give y'all a few minutes to complete it. If you're at home, just play the video when you're ready. For talk, I'm going to give y'all like 5 minutes to do it as a team. Okay? When you, what you're doing is you're determining whether it is true or false. Put a T for true, F for false, but be able to back up why. Okay? Like if it's comparing two numbers, have the numbers that you can compare. Pause and play when you're ready. All right, let's look. The first one was false. Second one false. 3 was false. 4 was false. 5 was false. 6 was true. 7 was true. False, false, false. Yeah. Oh. Can I clarify on any of those? Again, actively look. Trigger, yes, sir.
So how is it 8 true?
Okay, number 8. It asks the mode of the data is 70. And the mode is, so what's the question? The mode of the data is 70. So the mode is the one that repeats the most, right? I only see 70 once. The mode would be 40. Do you see that?
Yeah.
Yes? Pause. I cannot hear. Number 10, it says exactly 50 because it says digitals. Oh, yeah, I did say it should be true. Sorry, the last one should be true. 1 second. No. We said it was false. We looked at, okay, starting from the beginning, it says exactly 50 digital yearbooks happened in week 2. So in week 2, the digital is the shaded one, which is 30. So that would be false. That should be false. Okay, anything else? Yep.
How would you solve the question 5?
So we haven't calculated exactly. We'll do percentage change later this year. But so what it says is there was a total of 116 in V3, 50% more than 50. So if you're trying to figure out 50% more than the number, again, week 2 was 50. 50% more would be half, right? And half of 50 is 25. So if I was calculating a 50% increase, that means adding half this value. So that'd be adding 25 to its original. So that'd be 75. We'll do actual math for that later in the year, but that's a quick explanation of it. Yes, ma'am? As long as you got false, you got it. Okay. Other questions? All right. So again tonight, or some reminders for tomorrow. First, you will have a ticket tomorrow at the beginning of class. So we're not going to do an activities review, but it's going to be on dot plots, leads, histogram, shape distribution, skew, and comparing graphs. So look over that stuff. Test review is due Wednesday, so maybe I would do the next 3 or 4 problems so that you're not leaving it to the last minute. Go ahead and take a minute to update your weekend glance right now, and that's it for y'all online. Thank you.